Hello and welcome to my channel. I am the PASCAC tutor. I'm available for virtual tutoring in a variety of subjects, mostly math and science. I'm a certified biology and chemistry teacher with many years of experience, and I've had many years of experience tutoring as well. In person, $50 an hour if you happen to be in the Pascagoula Valley area, which is in northeastern Bergen County, New Jersey, about 6 miles west of the Hudson River. $40 an hour for online virtual tutoring, just as you're seeing me now. So let's get right to it. Today, we're going to talk about atomic theory. And there's a lot to know about atomic theory. This is going to be a short one today, and I'll explain what we're going to cover. So atomic theory, and particularly subatomic particles, is what I'm going to talk about today. Atomic theory, subatomic particles. And we're going to discuss how to determine the number of subatomic particles for a particular atom using the periodic table. All right, first, the number of the subatomic particles, there's 3 of them. We've got protons, we've got neutrons, and we've got electrons. I usually write it as E minus. Those are the electrons. Of course, neutrons have a neutral charge, electrons are negatively charged, and protons are positively charged. So how do we determine the number of protons, neutrons, and electrons for a given element? Well, let's take a look at an element. Like, let's use boron. You see here, boron is number 5, and it's got 10.811 written below it. B is its symbol, and the name is written below it. You should have your own periodic table out and be following along with me. You need to learn how to use the periodic table if you're going to be a chemistry student or even a biology student studying biochemistry who has to know this stuff. So I'm going to rewrite this here. Boron has a 5 above it, and it has a 10.811 below it. I'm just going to go that far. All right, so using that information, we can determine the number of protons, neutrons, and electrons. Well, let's start with protons. That's pretty easy. The number written right here is the number of protons. This number is called the atomic number because it is the number of that atom. Every atom or atoms of every element on the periodic table have a different number of protons. That's what determines the atom, the number of protons. If I have a boron atom, I have 5 protons. If I add a proton, it's not boron anymore, it's carbon. Add another proton, and now it's nitrogen. Add another one, and it's oxygen. So you could see that the periodic table is laid out by atomic number in order. That's an easy one. In a neutral atom, the number of protons should equal the number of electrons, and it does. So this is an easy one right here. Well, first, let's make ourselves a little chart here. We've got our number of protons, number of neutrons, and number of electrons. And the number of protons for boron is 5. 5p, 5 protons. Then, if we know the number of protons, we know the number of electrons. In a neutral atom, there should be 5 electrons. All that's left is to find the number of neutrons. Well, that comes from this number right here. This number is the atomic mass. And here's the trick. When we round the atomic mass to the nearest whole number, it makes this number become the atomic, not the atomic number, the mass number. So let me say that again. When we take the atomic mass from the periodic table, which is a decimal, and we round it to the nearest whole number, and so to round to the nearest whole number, I have to look to the next digit over to the right. And when I do that and round that number, that mass, to an integer or a whole number, I create what's known as the mass number. So the mass number for boron What's 10.8 rounded to the nearest whole number? That's 11. Good. So the mass number equals 11. Now, that mass number is the sum of the protons plus the neutrons. So take a moment to digest that, because that's probably the most challenging part of this. It's easy to read the number of protons off the periodic table, and then whatever the protons is, the electrons are the same exact number, assuming you don't have an ion, you have a neutral atom. So all that's left to do is to do a little bit of math, a subtraction really. Take a look. You round this number to find the total number of protons plus neutrons is 11. Well, I know there are 5 protons, so if I subtract the protons out of this number, all that's left is the number of neutrons. You see that? So let's take 11 minus 5, which is the number of protons. 11 is the protons plus the neutrons. And when we get rid of the protons by doing the subtraction, what's 11 minus 5? 6? Yeah. 6 neutrons is what we have. So there you go. We have 5 protons, 6 neutrons, 5 electrons, and that is in a neutral atom of boron. Sound good? Let's do another one. Actually, let's do a tricky one, and then we'll go back and do a more standard one. Let's look at hydrogen. Hydrogen has a 1 above it, and it has 1.007 below it, 1.007 below it. How many protons? Remember, we find the number of protons by that one number, the atomic number. And here's, if you don't have your periodic table out, there's hydrogen. I'm not lying. It's got a 1 above it and another 1. That's a different one. We're looking at this one, and 1.00794, I just rounded to 1.007. So how many protons? It's written right there. One proton. How many electrons in a neutral hydrogen atom? Good. It has to have the same number of protons as electrons. All that's left is to do that rounding and subtracting. Think of it that way. To find the neutrons, you round and subtract. So what's 1.0 rounded to the nearest whole number? That's just 1. And 1 is the sum of the protons plus the neutrons. And we know that it has 1 proton that we're going to subtract out of this. So how many neutrons are there in hydrogen? Yeah, weird. It's 0 neutrons. It's weird because it's the only element on the periodic table that has no neutrons. So often in chemistry textbooks, when they're referring to hydrogen, a hydrogen atom, they might just call it a proton. Okay, you want to do one more, and then we'll be done. This is pretty easy stuff. So let's look at something a little bigger. How about, let's do argon. Argon, noble gas number 18 on the periodic table. So we take our argon, I'll rewrite it for you here, AR, there's the symbol, it's number 18. And we can see it has a 39.9. I'll stop there. 39.9 written below it. So protons, neutrons, and electrons. How many protons does argon have? You could see it right there. That's the number of protons. That's easy. So we got 18 protons. How many electrons should it have if it's neutral? Well, it has 18. Piece of cake. And then let's do our, what were the 2 steps? Round and subtract to find the number of neutrons. So we take that 39.9 and we round it to the nearest whole number. And remember, you look to the right to round to the next digit over. So 39.9 rounds to what whole number? Good, 40. And that's called the mass number, by the way. When you do that rounding. Up here, it's called the atomic mass. But when you round it to a whole number, it becomes the mass number. Numbers are integers, whole numbers. And remember, that's the protons plus the neutrons. And we already know how many protons it has. So if we just subtract out the protons, we find the number of neutrons. Let's subtract out an 18. If you wanted me to show the math here, that's what it looks like. So there are 22 neutrons. What do you think? Pretty easy, right? So Some of the other things you'll need to learn about after you mastered this skill is what happens when you change the number of protons in an element. Well, that's easy. I think I might have already mentioned that. Each element has a unique number of protons. So when you change the number of protons, you actually change the identity of the element. From oxygen, which has 8 protons, if you add a proton, then you create a whole new element, fluorine, which has 9 protons. If you subtract 1 from oxygen, a proton from oxygen, you get 7 protons, which is nitrogen. So when you change the subatomic particle of the proton category, you change the element completely. When you change the number of electrons so that it doesn't match the number of protons, well, you didn't change the element, but you now have a charged particle. Those are called ions. Cations are positively charged and anions are negatively charged. So that's something you would learn next. Then finally, what happens when you change the number of neutrons in an element? Well, think about what the number of neutrons represents in terms of the overall scheme of things. It's part of the whole mass of an atom. So changing the number of neutrons isn't going to change the identity of the element, because that would be done by changing the number of protons. But when you change the mass, you get the same element, just of a different mass. And so elements that are the same but have different masses, the same element with different masses, are called isotopes. So changing protons, you change the element completely. Changing neutrons, you get the same element, but just a different isotope of that element. It just has a different mass. And changing the number of electrons gets you an ion. Positively charged ions are cations, and negatively charged ions are anions. So I hope this helps for you to learn this part of atomic theory, specifically just related to subatomic particles and how to determine the number of subatomic particles from an element on the periodic table. Quick review at the end here. The number of protons is written right above the element, or the smaller of the two numbers, or the integer, because you can't have a fraction of a proton. So that's right on the periodic table. That also then tells you the number of electrons in a neutral atom. And then you just have to do a 2-step process to find the number of neutrons. Round and subtract the number of protons, and that will give you the number of neutrons. Any questions, reach out to me. Let's hear from you in the comments section. And again, I'm available for virtual tutoring at $40 an hour. At least that's what I'm charging now. Hopefully it'll stay that way. It's one of the best deals in America, and probably certainly in Bergen County where I'm sitting now. Biology, chemistry, environmental science, test prep, ACT, math, science, AP, ASVAB. If you're trying to go into the military, you got to take that test. You got the GRE as well. Algebra, pre-calc, trig, geometry. You can scan my QR code here or in the channel icon. Thanks for joining me, and I will see you next time.